radio, isn't it? All right. I had a friend once who told me that they really like they write a bunch of songs, but they don't know how to play music. They write songs all the time, but they don't know how to play music, so they don't ever play them. What do they really write? They're poems. They're not songs, they're poems if there's no music, isn't it?
Like they can't do the instrument part? Is that what they mean?
Yeah, like they don't play it with music, they just write the words to it. But they said they write songs with no music, and they think it's just called a poem. I mean, it's not that like not good or bad. It's, I don't know. Michael Jackson didn't know music.
What?
Yeah, he didn't know notes and he couldn't play instruments and stuff. But he would go into the studio and be like, "So I want you guys to do," and he would do that, and they would be, "Oh, okay, here it is." Like people would make it for him, but he knew the sounds. He just didn't know what they were. Anyway, here we go. I am told with initial volume of 2 liters. We had that yesterday. I'm still confident in that. I know the initial temperature is 20 Celsius. I'm comfortable with that number, but I hate it. Why?
Kelvin.
It ought to be in Kelvin. So, one thing that I do, especially if I'm low on space, which I am here, is one, I change red colors for some reason. Did I really? I don't know if I did. We'll see. Okay, if you want to go from 20 degrees Celsius to Kelvin, what would you suggest we do? I'm going to add 273, and I think I can do this. What's 273 plus 20? 293 what? 293 Kelvin. It feels so weird. There's no degree with Kelvin. You take this number, and we'll even go ahead and write this out. Right now it's in Celsius. That's an issue. If I want to get to Kelvin, I'm going to do this. So I'm just, because that's our rule for Kelvin. That's a conversion. That's just the conversion to go between Celsius and Kelvin. 293 Kelvin by adding 273. Okay, is there anything else that I know? So I want to be really clear here because nowhere in this problem, and you guys are right, it is a final temperature. But anywhere in this problem do I explicitly, which I use that word I feel kind of often. You guys know the difference between explicit and implicit, not with language and songs. So you see your expletives, yep, you do hear it as bad word. Explicit language is not bad. Expletive language, they're very similar sounding words, and they probably have the same roots. Explicit means outward. So right now I am explicitly describing this word. Okay? Explicit is me saying out here. It presents very clear. Yep, so explicit or expletive would be the words it would use. It's very presenting bad language is what it is. Okay. Explicit is just outward. Is really, especially in like math and science and things, explicit is outward. If I ask you, how are you feeling? Is that within yourself or is that outward? Implicit. Implicitly is just something that's already like it's inside of you. Explicit is outside of you. So explicitly stating stuff is me like doing this right now. Okay, so with that in mind, do I ever explicitly tell you the temperature of the balloon at the end? Not exactly, kind of. In a way I do, right? You guys are logicking, but this may be a gap for some people. I don't say the balloon gets to 3 degrees Celsius. The what does?
The fridge.
The fridge. Now, we're going to use our mighty powers of logic. If I put a balloon inside the fridge and I leave the fridge closed, will the balloon eventually get to the same temperature of the fridge?
Yeah.
It'd be weird if it didn't. It wouldn't be a good working fridge in that case. So, although I tell you the temperature of the fridge, that is really and truly the secret final temperature of the balloon, right? And then so just make sure that we're there. T sub F is what? So it's 3 degrees Celsius, but I kind of hate it. Because I need to add 273 to that. To get 276 what? Kelvin. Okay. We now have all that information. We know the initial volume, final temperature, and initial temperature. What am I trying to find? The temperature? I already know. It's 276 Kelvin. The volume of the shrunken balloon. Again, this is explicitly stated or implicitly stated? Do we write out the word shrunken? Like, is it very clearly that it's written there? Explicit. Explicitly stated. Okay, I want to find, how do I denote that? V is volume, and V what? F. Yeah, V sub F. Now, here's kind of the workaround with this. With math, is 2 equal to 2?
Yeah.
So 2 is equal to 2 here. Is 2 equal to 2 if I switch sides? Can I then switch this around what's on the left and right of the equal sign if I wanted? Okay, and I do this because normally it is more comfortable for you guys to have what you're trying to solve where in your equation. Typically, you do it on the right, Angel? It doesn't matter at all. Is it more natural for you to say x equals or x equals 5 or 5 equals x? And that's okay, like there's no right answer. Because I'm after VF though, I'm gonna put that one on the left. I know that we're using Charles' law right now. VF over TF is equal to VI over TI. Now, I always will default automatically to just writing down and solving the formula as it is, and then I'll plug in numbers after I've rearranged it. I'm trying to solve for what thing here, King? Just VF. I don't even need TF, just VF. Okay, Riley, on the left side of that equation, I have VF. I can see it. What am I dividing by? Good, I'm dividing by the final temperature. Lando, how do you undo a divide? Multiply by the same thing, right? What should I multiply that by then if I want to solve for VF? So are you guessing right now? So I'm going to rephrase this because I think you'll know this answer, but you were also in thought when I called on you. What am I dividing VF by right now? Okay, so to undo a divide by TF, what do I multiply by? It changed just now. Your letters did, right? How come? If you don't know, that's an okay answer. Do you agree that if I'm dividing by something, I just multiply by that something to get rid of it? So I think we're getting kind of goofed up here. I'm going to multiply the left side by TF, the left side of the equal sign. What else should I multiply by TF? The other side of the equal sign. Good. They gone. Lay, you had your hand up. Was it to answer the question? Yeah, you can. Okay, looking at that, at this point in the problem then, I have the following. VF, and I meant to change back to green, but that's okay, equals VI over TI times TF. Do I know these three values right here? I think so. What is VI? The initial volume. 2.0. Now, I'm going to include my units, but we're going to see something nice happen. L is liters. What's the initial temperature? Hate it. Love it. 293 Kelvin. Times, what's the final temperature they're going to multiply by here? Hate it. Wait, 80. Why 80? I don't think so, but we'll figure out why. So what's the final temperature that I'm going to plug in right here? 276 Kelvin. Now, the units here are helpful to ensure that we have everything right. On the right side of this equation, the only thing that I have written down anymore, Mark, what are the two units that show up anywhere in here?
Isn't it just two?
Hold on. What's the two different units over here? Kelvin K and, you remember what that one is? Somebody hook it up. What's capital L? Liters. Okay. Do I have a Kelvin that I'm multiplying by? Yes. Am I dividing by a Kelvin? What's any?
Oh, 1.
Definitely by a Kelvin, right? What happens to these K values then?
They divide out.
They divide out. Love it. Okay. Crosses out. They gone. Bagoo, bagoo. What's the only thing I'm left with? Liters. What am I trying to find? All right, I'll take that. I'm looking for volume, which is measured in liters. I'm convinced. Now, when you do this, Landon, it is definitely just 2. You were correct. What's 2 times 276? Somebody with a calculator, hook it up. I agree with that, I think. 552 over 293? Try your division again, Kennedy, because I think you might have multiplied. When you divide this, I think it comes out to be 1.9, doesn't it?
Yeah, I died. Yeah, that's what I said.
Okay, we get 1.9 liters in the end. Now, check this out. Does this actually make sense? If I put a balloon in the fridge, should it get bigger or smaller?
Bigger.
Have you guys ever walked out of Safeway when it's cold with a balloon? Does a balloon like blow up and pop, or does it shrivel and look sad? Shrivels and looks sad. So let me ask that again. Should the volume increase or decrease? It decreases as you get cold. Balloons shrink in the cold.
We just multiplied to 2 every third, so that's what we counted.
Yep, that's what I think you did. I'm sorry? So they will, so it gets weird because when you start throwing in pressure, then things start to change a little bit differently. Okay. This problem, doable, super hard? Doable. Do you want to try one more?
I do a little circle.
This is just always how I indicate this is my last part. This is my answer. Okay, you're good. Now, if I were on a quiz or a test, should I really stop here? No, the final volume of the balloon is 1.9 liters. I did 2 times 276. Yep. It's 552, and then we divide it by 293. Get the right number that time? Awesome.
I don't know how I got 4 million.
That'll happen. That's my bad.
I multiplied everything.
I think you did too. But all right, I want you guys to work with your neighbor on one more real quick, and then if we're good and everybody can get good answers out of this, I'm fine with it. We'll use a little editing magic. Ah! All right, we'll see if that works. All right, here's the other one though. Okay, here's our problem. We have a gas, doesn't matter what it is, it's heated and it expands from occupying 1 liter of volume or space to 1.5 liters of volume or space. I want to know if the initial temp was 5 degrees Celsius, find me the final temp. With your neighbors or with me as I'm walking around, if you're not sure how to do it, I need you guys to write down your knowns, what you're supposed to find, and the equation that you ought to use. Cool, I'll give us a couple minutes. I'll be walking around. Don't hesitate to ask questions if you have them. Lando, since I'm making you wait for the problem, you better be doing the what?
Problem.
Indeed. If you are doing this problem, and I'm seeing some people get hung up on a little bit of the math part, we will review really quickly just a skosh of math as we're looking at it. What do you know, though? This is required for us to write. Things that we know about this problem that are relevant. King, give me one thing. F sub I, you mean not F? Is that T as in tango? Temperature, right? The initial temperature is 5 Celsius. Now, 5 degrees Celsius is all fine and dandy, but I don't really want 5 degrees Celsius. Lando, I don't want Celsius. What do I want? How do you go from Celsius to Kelvin? So check it out. I'm going to add 273. And then if I just write equals underneath without ever writing another variable or letter here, is it common enough for you guys to know that I'm still talking about the initial temperature? Yeah. Like if my equal just goes straight down, do you know that the left side just didn't change? Yeah. Is that common or is that something only I do? Okay. So here's my initial temperature. It's 278 Kelvin. Love it. What else do you know? King. My final volume is 1.5 what? Definitely not Kelvin. Liters for volume. Okay, what else do I know, Trace? I know my initial temperature. I know my final volume. What is my initial volume? Now I'm going to write 1.0 just so it looks consistent. At this point, I just need thumbs up or thumbs down. Thumbs up says I can do this part without any issues. Thumbs down says I can do none of this, somewhere in the middle. How do you feel about writing your knowns? All right. Kyle, where do you feel as though you're struggling?
How did you get the TI?
So if we're given Celsius, the rule is to go from Celsius to Kelvin is you just add 273. That's just the way that we change between them. That's the only weird thing I hope that happens here. Anytime Celsius to Kelvin, add 273. Kelvin to Celsius, subtract it. Okay. And we'll get more practice, I promise. What am I trying to find here?
The final.
The what? The final temp. How would you write that? T sub F. Now, here's where your math ability, which this is not a math class, but I hope this shouldn't be a surprise. Do you need math to do physics? Absolutely. The equation that we need is this. Let's see, I'm dealing with temperature and volume. Is that Boyle's law or Charles' law? And what does Charles' law tell me? So that's okay if you don't remember. You don't have to remember it. Tell me.
Temperature and
The initial velocity.
Nope, never velocity.
I mean, sorry.
Kennedy, go ahead. Sorry.
with an enclosed gas held at
So you're giving me the wordy version. Read me the formula. That's all I care about. What divided by what?
its. Wait, what is the formula?
The initial.
Oh, is it the V I what?
VI over
Oh,
TI?
V sub I over T sub I equals VF TF.
Okay. Now, here's a couple things that we need to be aware of. I would always advocate work smarter, not harder. Every single time. Right now, what am I trying to solve for? Which of those?
TF.
TF. If I said which side of the equation is TF on, y'all can tell me, I think.
Left.
This side is the right, I believe. Okay. Is it in the numerator, the top, or the denominator, the bottom? The denominator. When you solve for x in algebra, do you ever solve 1 over x equals, or do you just want x equals?
X equals.
You just want x. In the numerator, right? You just want x over 1 is what your goal is. Do I want this in the denominator? No. So, the language I think that Mr. Russell uses is going to be the same language I use here. Do we have in proportion right now?
Yes.
Fraction equals fraction. What am I doing with my hands?
Moving them.
I'm crossing, and you're going to cross what?
Multiply.
Cross multiply. Yes, no, you guys have looked at cross multiplication this year.
Yes, I hate it.
Okay. If you haven't, and you don't love that idea, cross multiplication is easy, but I know that it might not always seem that way. If you want to cross multiply, you can do it like this. Just straight through. If there's an equal sign and two fractions, just multiply straight through. Now, alternatively, I said this before, if I have two fractions that are equal, and I flip this one, if I flip that one, am I still good? If I flip one side, and I flip the other side, did I do the same thing to both?
Yeah. Square equals.
They're still equal, which means, would it possibly be easier for anybody? And I'm just going to let you think about this. If I wrote it like this instead, TF over VF equals TI over VI. I still use the same letters. They're still the same fractions. They're just flipped. Is that one easier to solve for TF? And I don't know if there's, like, that's a subjective, it's entirely your opinion on that. Would you rather solve the purple one or the red one? Doesn't matter. I would rather solve the purple, but if it doesn't matter, and this wouldn't be helpful, we'll just use red. So this looks scary. I promise it's not. Right now, if I multiply, I'd simply have VI times what? If we cross it.
VI over TI.
VI times what if we diagonal here? If we cross this. TF. Notice, TF times VI or VI times TF equals, I get TI here times what? VF. We're just cross multiplying. Which one of these things am I trying to solve for? TF. Right now I have TF on the left side and it's being multiplied by VI. Do you guys agree with that?
Yep.
How do you undo a multiply by VI? Divide by what? VI. If I divide this side by VI, they gone. What do I do on this side? Divide by VI. At this point, what's the only thing that remains on the left side of that equation? What am I trying to solve for? Can I now plug in the values for TI, VF, and VI that I have written on my notes? Absolutely. At this point is where I would wait to plug in every time. What is TI, my initial temperature?
278.
So 278 K. What is my volume at the end? 1.5 liters. And what is my volume initially? 1 liter. Now the reason I'm writing this out, the units eventually start to matter more and more. We're almost done with the physics part of this course and moving to chemistry. But do you see any units on the right side that'll divide out? Any units that are same in the numerator and denominator? L. Take the L. Right? All right. Now I just need to do 278 times 1.5, which somebody already has, I'm sure of it. 278 times 1.5, what do you get? I don't know the answer. 417?
Yeah.
Okay. Now, what's the only unit that I had left in my numerator? The L's are gone. Kelvin. Did we get a temperature for our answer? Now, does it really make a whole lot of value for us? If I said, what's the temperature? You said, it's 417 Kelvin. Does that really do anything for me?
No, it's
No. What's a better way to think about it? Let's go back one more time to get our temperature in Celsius. How do you go from Kelvin to Celsius? Subtract 273, and we'll get into Celsius. And what do we get? Say it again? 144. Okay, I thought you said 544, and I was trying to get in my head how that could possibly work. Awesome. When is it 144? You subtracted 73. You need 273. Okay. Now, this section is pretty mathy. This is the mathiest one for the whole section. This has been a pretty mathy chapter overall. For the break, I'm going to give you guys tomorrow at some point in class, I will give you your stuff to take home and complete over the break. I want you guys to do some homework for me tonight, though.
Do we have a quiz tomorrow? I thought you said.
Yeah, but it's going to be, we'll be chill about it. I'm not going to make you do note cards or stuff.
Can we make a note card?
I mean, you can, but I'm going to let you use your notes.
Oh, we're gonna.
I'll let you use your notes. For
Oh,
whatever, this,
so much.
section 3. Just section 3.
Okay.
Yep. Boyle's Law, Charles' Law, what else is in section 3?
Probably the other law.
Those are the two.
Oh, and me and Bradford.
Boyle's and Charles. Those are the only two laws we saw. Nope, that's not this section. Yeah. 14.3 is literally just Boyle and Charles. Okay. Looking at it then. Homework. And I'll go ahead and put it on the classroom because I'm going to forget. You are my sunshine, my only. Still 14.3. This is homework for 14.3, which you will find lovingly waiting on page 373. And you get the privilege of working problems 24 through 28.
I'm so proud. What date? What's the date?
326.
Wow.
Tomorrow's the 27th.
What's the year?
24.
Yeah, I'm really trying to. I'm just telling her all the wrong stuff. I was road 25. That's weird. What's this?
It's actually the 26th.
I don't know why I thought we had a break coming up, like spring break.
Oh no. Summer break.